Hey besties, is the tinted? Oh my god, I know it's a bad intro. Yo, okay. Let's do it one. Hi guys, is the Tintita back again with a math video. So don't mind my voice, but today we're going to look at probability because someone commented and he or she was like, "Girl, please do probability." So that's why I'm doing probability, and this is for oh my god, this is for grade 11 and also the grade 12. You can use this for revision. So 9.1 says, obviously I had to do a past question paper so that y'all can understand it more. So that's why I have 14 marks on the table. So for any two events, A or B, it is A and B, it is given that probability of A it's equals to 0.35, probability of A or B is 0.61. So we are asked to determine the probability of B if probability of A and B are mutually exclusive. So I want us to look at the word mutually exclusive. Okay, so when we say that the two events are mutually exclusive, we actually mean that the probability of A and B it's equals to 0. Remember, in probability we have what we call, or what I like to call, the mother equation. This is the big equation, this is the main equation, which states that, let me just write it in red, the probability of A or B it's equals to the probability of A plus the probability of B minus the probability of A and B. Okay, remember n represents and this u represents or in probability. So just make sure that you master this one because the examiner might try to trick you with this too. All right, so that is exclusive. Sorry guys. So that's what I just wanted you to know first, that in mutually exclusive events the probability of A and B it is equals to 0, but in independent events, we have two events that you need to know that are really important, that are always there in the question papers. The mutually exclusive events, the probability of A and B is equals to 0, which means that you're going to do what? To put 0 here. Simple as that. Now let us look at independent events. So when we say that the events are independent events, it really doesn't matter, guys. Yeah. So in independent events, the probability of A and B will change. It will be equal to the probability of A multiplied by the probability of B, which means that this is what you're going to put where? There, because this is the main, or this is the mother equation. This is the mother equation. So when we say that there are mutually exclusive events, you're gonna put 0 in probability of A and B. Why? Because you say that the probability of A and B is equals to 0. This is more of like a rule of mutually exclusive events. But now when you're looking at independent events, the probability of A and B it's equals to the probability of A multiplied by the probability of B. So that means that when you are asked to prove if they are actually independent events, that means that the probability of A and B will be equal to probability of A multiplied by the probability of B. Okay, so let's go back to the question. So we are asked to determine the probability of B if the probability of A and B are mutually exclusive. So you're going to write you firstly, I love writing the main or the mother equation. This is what I like to call the mother equation. Okay, so it's 9.1. You're going to say, okay, the probability of A or B, it's not, oh yeah, is it all? This is confusing, but like, make sure you don't confuse yourself. Yeah, it's correct. It's correct. Probability of A plus probability of B minus probability of A and B. So this is basically the mother equation. And now because they said the word mutually exclusive, that means that I'm going to write my new equation for mutually exclusive, which will be equals to the probability of A plus probability of B. I'm not going to write minus 0 because it's basically the same thing, okay? Because any number will be subtracted by 0 is that number, okay? Now, let us simply find the probability of B. We are given the probability of A, which is 0.35. Let me just write it down so that I just don't come back again. This is the probability of A, and the probability of A or B, it's equals to 0.61. Sorry guys. Okay, so you're going to now substitute. Remember, we are asked to determine what the probability of A of the probability of B. We have the probability of A and we also have the probability of A or B, which is just so simple. I'm just gonna substitute. The probability of A or B is 0.61. It's equals to the probability of A 0.35 plus the probability of B. It's more like you're solving for X. We don't want 0.35 on this side, so she's gonna jump the equal side, and when it jumps the equal side, it's gonna change its side. So the probability of B will be equal to 0.61 minus 0.35. I love writing the one that I'm looking for on the left hand side, so I just swapped the places, so the answer will be equal to 0.61 minus 0.35 is 0.26. So that means that the probability of B is 0.26. You're done. Simple as that. You just need to know that in mutual exclusive events, probability of A and B is 0. Once you know that, you're done. Now let us move, or why am I going back? Let us move to independent events. So they said if they are independent, guys, don't come for my, one thing about me, I don't really care about the what you call the spelling when it comes to math, but I should start considering it because I also do English, but okay, I will try my best, trust me. Independent events. Okay, so we are asked to determine the probability of B there also. So what you're going to do, I told you, it's to always write the main or the mother equation. So the probability of A or B, it's equals to the probability of A plus the probability of B minus the probability of A and B. Now, the probability of A and B is going to change because we're looking at what we call the independent event. I told you guys before that the probability of A and B in mutually exclusive, if in independent events, it's equals to probability of A multiplied by the probability of B. So we're going to substitute it and write our new equation. So the new equation says the probability of A or B, it's equals to the probability of A plus the probability of B minus probability of A multiplied by probability of B. Whew. So that's our new equation. We can just simply substitute and find the probability of B. So we are already given the probability of A or B, 0.61. It's equals to 0.35. That is the probability of A plus the probability of B minus 0.35. You're going to substitute, multiply by probability of B. So 0.61, it's equals to 0.35 plus the probability of B minus, and then you're going to multiply because it's basically multiplication. 0.35 multiplied by P, so it's gonna be negative 0.35, the probability of B. Did I say it correctly? No, let me just go back again. You're going to say 0.35, negative 0.35 multiplied by the probability of B. Take this probability of B as X. You're done. You're done. If you take it like that, you're done. You got, probability, okay? So now when you simplify it, it's going to be oh my gosh, let me take this baby 0.35 to this side. so that I can be left with the probability of B only. Okay, so it's gonna be 0,61 minus 0,35. It's equals to, and then this one is 1, so it's gonna be 1 minus 0,35, because I told you to take probability of B as x, so it's basically 1x minus 0,35x. You kind of get it, I know. Okay, if you don't get it, don't forget to comment down below. So it's going to be 1 minus 0,35, which is 0,65. So it's going to be 0,65, the probability of B. So what is 0,61 minus 0,35? And that is 0,26. It's equals to 0,65, the probability of B. And you're gonna divide by what? Correct, I'm gonna divide by 0,65 on both sides, and that means that my probability of B is equals to 0,4. So this is the first part of the question paper. Make sure you comment down below the parts where you didn't understand, then I'll make a specific video for that. But don't forget, I'm still going to do 9.2. It's just that I don't want my videos to be too long, but yeah, I'm gonna do a competency table in the second part. So I hope you guys have understood it. Don't forget, the main thing in this video is to know that the in mutually exclusive events, probability of A and B is the baby zero, and then in independent events, the probability of A and B is equals to probability of A multiplied by the bigger sister, the probability of B. Simple as that. Okay, so you just need to master that for now. Okay, so I hope you guys have enjoyed the video. Bye for now. Peace. And please, I'm wishing you all the best in your examination, and please don't make silly mistakes.